So in this session, we're looking at structural isomerism. All right. Now, organic compounds can have the same molecular formula. When we talk about molecular formula, we're talking about the different types of atoms and how many of each we have. And they can also have different structural formulae, meaning if you were to draw them, they look different, but they have the same molecular formula because their atoms are bonded differently. Now, this is called structural isomers. Structural isomers are organic compounds which have the same molecular formula, but different structural formulae. And the term structural isomerism is the occurrence of two or more organic compounds with the same molecular formula, but different structural formulae. So if they were to look different, the arrangement of the atoms, that means they're going to have a different name. The compounds will have different names, right? And we're going to come to the naming soon enough. So isomers are formed by branching. We can have side branches composed of one or more carbon atoms. And that can happen, for example, if the molecules have 4 or more carbon atoms. Let's look at our example here. We have the compound C6H14. All right. So C6H14 has 5 isomers, but they've given 3 of them for us. So if we look at the first one, we have a straight chain. There's nothing happening there, no branch, nothing. So we know C6 tells us how many carbons? How many carbons we have in this compound here? The first one. And how many hydrogen? Come on, students, how many carbons, how many hydrogens do you see? Hey, students?
6.
6. Good. So we got 6. So what about the second one? You got 6 carbons and 14 hydrogen. How many in the second one? On quickly.
6 in the second one, 6 carbons.
And how many hydrogen?
12?
Count again. You're missing hydrogens there.
6 carbon. 14, miss.
14. Good. Look at the third one now. How many carbons and how many hydrogen?
6 carbon. And 14 nitrogen.
Good. So that means all 3 of these guys have the same molecular formula. This is molecular formula I'm circling here, right? But when you look at how they're arranged, don't they look different?
Yeah.
Good. So these are structural isomers. We call them isomers, structural isomers, right? Of C6H14. Now, what's the name of this compound? Can you name this one for me? We can come to the branch later. Name this one. 1, 2, 3, 4, 5, 6. What's the prefix there? We just look at this. Let me back up. So the prefix is going to be what? If you have 6 carbons, what's our prefix? Prefix is? Look in the table there.
X.
X. Good. And then we look at the functional group. What did you see in that compound? Only that you were seeing there. What's the ending we can put with a hex? Ooh, going too far.
Pardon?
What's the ending we put in with the hex? Remember naming the compound. Look at, I'm not reached there yet. Good. So this is our compound here, right? So
Mm-hmm.
we have hex. That's 6 carbons. What is the functional group? Can anyone remember the functional groups? So we looked at the 4th functional groups we just looked at. What type of bond is in this compound here?
Single.
Single bonds. And so the ending, so the homologous series is alkane.
Hexene.
So it's hexane we have here, right? Because the ending
Mm-hmm.
for the homologous series of alkanes is ANE. So we have hexane. So this is hexane.
Yeah.
Then we come to this guy here. We have a branch on the 2nd carbon. And the 3rd one has 2 branches on the 2nd carbon. We're going to learn how to name these guys just now. We're going to come back to them, right? Now they give us a little example at the bottom. Is this an isomer here? The 4th one at the bottom here? What do y'all think? Is it a branch? At the end there, is it a branch? Actually, it's not. This is not an isomer. All they did for A here is to turn this end carbon facing upwards. So this is not another isomer. And the second
Miss,
one, hi,
Miss, how you know when it's not an isomer?
because you can look at the position of the carbon. This is just a bend. They just bent this one. It's not a branch. Look at this one here.
Mm.
You see another carbon at the end here and it's in the middle here?
Yeah.
That's not a branch. But if you were to swing this around, you get the second one here at B. This is not different from B, from the middle one there. So this is not an isomer. So you gotta look carefully as to see where the carbons are. This one is like a mirror image of B. And this one is just a bending of the carbon at the end of A. So these 2 guys at the bottom here are not isomers. So you gotta look carefully at them. With practice, you get it. All right, so we're coming to how to name branch chain isomers. All right, this name has 3 parts. How many parts?
3.
All right. So our branches are called alkyl groups. For example, we can have methyl, ethyl, propyl, etc. And it goes on. All they did was to take the meth and add YL to represent the alkyl group. All right? So the first part gives the number of the carbon atom to which the alkyl group is attached. So we're going to try to name this one here. No, gone too far, gone too far. We can name this isomer in the middle here. So that's the one we want to name, right? So keep that in mind. This isomer we're naming, right? This one. So first part of the group is what? What's the first part? The first part of the group is our alkyl group, and we need to indicate the carbon to which it is attached, right?
Yep.
So, and the second part gives the name of the alkyl group. So we have to say which carbon is on first, then the name of the alkyl group, and the third part gives the information of the longest continuous chain of the carbon atoms. So let's go to our example. So what's the first part? You want the number of the carbon on which the alkyl group is on. And we have to take the lowest number. So we have to number these carbons. So we start numbering the end at which you find the branch, the alkyl group. And so I'm trying to get my annotation, my marker. So we start from this end and not left. We start right. So this is carbon 1, 2, carbon 3, 4, carbon 4, and carbon 5. On which carbon is our branch?
1?
No, look, this is 1. Is this where the branch is? No, the branch is on 2, carbon 2. So the first part we write is the number on which the branch is on. Then we have to name the alkyl group. How many carbons are here? How many carbons is
That's
here
your
on the branch? This is a branch.
that's your number.
What is the prefix there for 1 carbon? We got to go back. Meth, good. All right. So the group, the alkyl group, all you do is put on YL after the meth. So this is methyl. METHYL, methyl. So that's the first 2 parts, right? And then we have to look for the longest chain now. How many carbons are here now? 1, 2, 3, 4, 5. What's the prefix for 5? Anybody can remember? Remember, it's just like maths. Pentagon, 5, right? So this is pent. And what do you think might be the ending now? Look for the functional group for me. PEN. So this is pentane, right? The single bonds we have. So the name of this compound is 2-methyl pentane. That's this one. Let's try this little guy here now. So we now start numbering from the end closest which you see the branches, right? So where do we find our branches? We got 2 branches here, so we gotta count for 2, right? So which carbon do we find our branches on?
2?
2. All right. But now, notice it's both on the same. So we can put 2, 2. One is this way and the one is that way. So you count it for each branch. 2, 2. How many methyl groups do we have? 1 here and 1 here.
2.
So what we do, we put dimethyl
To represent the 2? Oh.
Because you have 2 groups there. Dimethyl. And what is our longest chain we are left with? So we got 1, 2, 3, 4. What is our prefix there now? Remember, meth, eth, prop, but, pent, hex, hep, oct, nano, and dec. So how many we have here? 4. So what is our prefix? Come on, girlies, give me this quick. We can get a whole day. But, right? B-U-T. And what's the ending we got put there? What's the functional group?
Butane.
Butane. The functional group is what? The carbon to carbon single bonds. So it's A-N-E. So this compound here is 2,2-dimethyl butane. Right? So that's how we do our naming with our branched. I'll have to give you practice for you to do tonight. I'm going to send you the questions in the group. Y'all understand so far the naming of the compounds? So remember, we use the 2,2 to tell us which carbon each methyl is on. That's why you have 2, 2. 2,2-di, meaning 2-methyl, and the butane is the longest chain. All right, let me get rid of these guys. Let's see that example they gave us there. Let's see where it is. So I gotta send y'all some questions to work, and we're gonna go through them at the start of tomorrow's class. All right, you're doing good, girls. Y'all understand so far?
Yes, Miss.
All right, all we need is some practice, practice, practice. All right, so we can have methyl, ethyl, propyl, butyl, right? Those are the branches that you can have. The only difference with this and the prefix is that for the branches, you have YL at the end of the name, right? Good. All right. We want to name this one. Let's see. Name this one for me. Name this one. Let's see if you get it right. Name that one for me. Remember, you have to start with a number on which the branch is on, and you want the lowest number. So in this case, you start numbering from the right-hand side. 1, 2, 3, 4, 5.
It's 2-methyl propane or pen. 2-methyl pentene.
Pentene, that's correct. 2-methyl pentene, and that's what we just looked at just now, actually. So that's 2-methyl pentene. Let me see if we can go to a question for you girls to work on. Let's see questions that they have here. Let's see, end of chapter questions. I don't want to rush too much on this naming. We can always come back to these guys later. Did they give us structures? Yes, look they have here. Can you name A, B, and C for me and see how you get along with these? Do number 9 for me. Remember the names of the functional groups too, right? The question 9. So we gotta do a little practice of the questions. I should have started at further up anyway. Y'all gonna be able to answer those guys. It should have been nice to start at question 7. Anyway, we're question 9 and type in the chat the names for A, B, and C. So I'm going to give you a little time to work that out. I hope you all can remember the prefixes, your homologous series, and you number the carbons on which your branches are on. And you also need to indicate where your double bonds are too. Okay, girls, what's the name for A? Come on, somebody give me the answer.
It's 2-methyl butane.
Yes, that's correct. 2-methyl butane. Anybody else got that? Hello. What's B? What's the name of B, no?
Miss me sure, but I think it's 1-methyl pentene.
1-methyl pentene. Yes, that can work, or we can say methyl pentene. And the last one.
Miss two the M word, man.
2? 2 what?
Some metal.
No, it can't be methyl. That's not a branch. That's not an
No, I know
alkyl
the
group.
the
It's the
mal.
alcohol you have there. So it's
Propanol.
2 proper,
Uh-huh.
proper. 2 what? 2 propanol. You're correct.
Propanol.
2 propanol. So you identified where the functional group is. 2 propanol. That's correct. What if you were asked to
Which one is
draw?
2-prom?
That tells you where the functional group is on the second carbon.
But it's not branch.
It doesn't have to be a branch. It indicates where the functional group is, just as how you had here, 1-methyl, and that's not a branch. Right? You see? Where the double bond is. You can indicate where the double bond is or where the functional group is. Right? Understand? Do you understand?
Yeah, miss.
All right. Good. Right? So 2-propanol, you indicate where the alcohol is attached on your formula there. Right? Try for me drawing these structures. I'm going to send it in a WhatsApp group. Hex 3-ene, you have 2-methyl propane, 2-methyl propene, and 2,3-dimethyl butane. Draw those guys. And we're going to wrap up on this today. I don't want to give you too much content. You have like about 8 minutes. So try these. We're going to take them one after the other. I'm going to give you some time to draw them out. So you're doing 10 now. I'm not hearing from anybody else really. It's just a few. I'm hearing from Nikayla. Why is Brian in this meeting? Brian, you're in the wrong class. This is a 5th form class. Yours is at 11. All right. So you're listening in though. Yes, girls. So draw these structures for me. 10A, B, and C. See if you can draw them. Now for hex 3-ene, or you could have written this C as prop 2-anol, right? I think that's the prescribed way. prop 2 and all. And hextrene, this tells you where the double bond is supposed to be found, right? The 2 here tells you where the methyl group has to be found, and 2,3 tells you where these two, notice it says dimethyl, so it tells you where these branches are to be found. Once you see YL, methyl, we know it's a branch, right? Work those out for me, and then we're going to draw them. If you're done with 10A, please inbox me privately in WhatsApp. Thank you. Shania, yours is incorrect. You should only be having 6 carbons, and you're putting in the double bond between carbon 3 and 4. You have something different there. Shouldn't be having a branch. Okay, students, our time is running down, so I'm going to work the first one and you send the others for homework, right? So I'm going to do A for you. Let's do A. So A is C. Remember how many carbons we have? Notice it says hex-3-ene. So our double bond goes here. The lowest carbon is 3. Then we have another one here. So we're supposed to have 6 carbons. And then we put in our bonds with the hydrogen. Notice we only supposed to have 4 arms of carbon, right? So girls, you owe me homework B and C, right? Our meeting is about to end. So this is hex-3-ene. Do you understand this one now? Shana, you gave me an incorrect diagram.
Yes.
Good. This is hex-3-ene. And you're going to put in the H's. Draw it out for me quickly. No, this is a little troublesome to draw on these little guys. All right, so do you have any questions before we go for today's class? I think all you have to do is memorize your prefixes, learn your homologous series and the functional groups, and you'll be fine to name these compounds. I'm going to get some past paper questions for next class. I have my past paper booklet, so we're going to work some of them. And this is your hex-3-ene, right?
Yeah.
Good. So we're going to end here for today. Thank you for attending. So we meet again tomorrow. Tomorrow at 9:30, we're going to start. Don't want to start too early because some of y'all might be sleeping late like me. I went to bed late. All right, so that's it. You want to stop the recording?